This episode of the Drone Radio Show is presented by Ascent Aerosystems, the leader in coaxial drones for mission-critical operations. Learn more at ascentaerosystems.com.
By year 2027, the emergency medical drone delivery market is going to be worth nearly $1 billion and probably more than that. My system is order and magnitude better performance, fully reusable, much faster, more range, more payload, more speed. So clearly my product can dominate a very, very large section of this market by 2027.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello everyone, this is Randy Goers and welcome to the Drone Radio Show podcast, episode 302. Is a jet-powered drone the future of medical supply delivery? Today's guest believes it is. Alexander Taits is CEO and founder of FusionFlight, a manufacturer of the Jet Quad, the world's smallest and most powerful jet-powered drone with vertical takeoff and landing capabilities. It's like an unmanned, scaled-down version of the Harrier-Jump Jet. With its high-speed capability, the company aims to be the leader of autonomous UAV medical delivery. Alex began his career in mechanical engineering, performing structural analysis for rocket engine and nuclear reactor components. He holds a master's in mechanical engineering from USC and is self-taught in the areas of control systems, software, and electrical engineering. Over the years, he has worked in a diverse set of industries, including military jet propulsion, semiconductors, robotics, and microsatellites. In this edition of the Drone Radio Show, Alex talks about FusionFlight, the company's Jet Quad, and how the jet-powered drone will revolutionize the medical delivery industry. But before we hear from Alex, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have an idea for a great show and want to share your experience, please contact me at randy@droneradioshow.com. So let's learn how the Jet Quad could revolutionize the UAV medical supply industry with Alex Taits of FusionFlight. Let's pick up the interview where I asked Alex to introduce himself.
My name is Alex Taits. I'm the CEO and founder of FusionFlight. I'm also the lead engineer, software developer, tester, and basically a man of all hats for the company. And since 2016, I have been developing a quad jet engine drone, the vertical takeoff and lifting capabilities that has a lot of very interesting new applications for the drone world.
Let's talk about the jet-powered drone. First of all, is it the primary product that the company produces?
The jet-powered drone is not only just the primary product, it is the first product, and it is essentially builds a foundation of the technology. What it really is a platform that consists of any number of jet engines that are equipped with thrust vectoring systems. And so this drone that I built is a small-scale version. It's essentially an entry into this technology. And you can build a lot of products based on this platform. For instance, you can scale it up. You can put on bigger engines. So now you can carry humans, multiple passengers on there, very heavy cargo. So there's a lot of places to go. But certainly what I'm doing right now is the starting.
Is anyone else manufacturing a jet-powered drone? Or is this its own niche?
It's a niche, absolutely. Really, nobody's doing anything even close to this. There are a few companies out there that have shown some either computer-generated videos of jet engine-powered drones, and some companies who have shown non-working prototypes, just lab bench prototypes. But all of those companies, all of their prototypes have the engines in a vertical orientation. And that's very important to say that for my vehicle, the engine's on horizontal orientation. And that's what really is the key that allows my technology to work. That is why I have successfully achieved flight about a year ago, since I've already gone through the process of trying out to build a vehicle with vertically oriented jet engines.
Tell us more about the vertical and horizontal orientation.
A jet engine can be pointed essentially in any direction to give you thrust, right? So if you imagine a jet engine, it sucks air from the front and it pushes very hot air out of its back. And that's how it generates the thrust, right? So most people, when they think of vertical takeoff and landing vehicle that uses this type of engine, they instantly think that, okay, these engines must be oriented such that their intake is at the top, pulling air in from the top, and you are pushing the hot air straight out of the bottom, just like you would with a rocket, for instance, right? And that's what everybody's trying to build. And that's actually where I started too. The big problem with this is that you're pushing all this hot air out of the bottom, and this hot air recirculates back into the engine from the top, causing the engine to really overheat. It also causes a lot of these problems called ground effects. And essentially, these are areas of high pressure, hot air that try to lift the vehicle and tilt it sideways and bring it sideways. And then there's a lot of other problems, like how do you ignite a jet engine when it's oriented in this manner? Jet engines are really designed to work like they are on an airplane, where they are sideways. They're mounted horizontally. So they're pulling air from the front and it's exiting out of the back. This, if you can find out a way to mount engines in this configuration, that's what's going to allow you to have that reliability and stability. And with my most recent vehicle, that is exactly what you see. The engines are not pointing downward. They're actually pointing sideways from the two directions. And then I use thrust vectoring systems, which is essentially a pipe that bends the flow from horizontal down to a vertical orientation. And that's what allows me to fly up from the launch pad.
So you're able to fly up by forcing the air downward. And then when it gets to a desired height, does it just switch over to the horizontal thrust?
And that's exactly the premise of this platform, is that not only you can switch the thrust from vertical to horizontal depending on your mode of flight, but you can also adjust specific angle between the two. Not just 0 or 90 degrees. You can go anywhere between 45, 35. As a matter of fact, you can dial that angle really precisely. And that is what also allows you to control the attitude of the vehicle, since tiny little changes in this angle will exert torques on the vehicle and allow it to always remain stable and steady.
Do you have a prototype or is it in production?
Yeah, I built a prototype, and currently I'm working on the pre-production, quote unquote, pilot model. Essentially, you can think of it as a second prototype, but one that allows me to slowly kind of connect to a production version. So the original AB5 jet quad, which has successfully flown, we had a 2-minute hover dating in October 2019. There's flight videos of that online and on the website. Now I've been developing over the past year the AB6. And what the AB6 does is takes that lab bench technology that has flown and really makes it into a vehicle that is mass producible. Every single one of its parts can be ordered in quantity so that a lot of these units can be assembled and each one of them will work reliably.
What are the benefits of a jet-powered drone, Alex? For example, what will it do that other drones can't do, or what will it do better?
First and foremost is the top speed. When it comes to cruising speed, when you need to go really, really fast somewhere, nothing beats the jet engine. Well, maybe with the exception of a rocket engine, but rocket engines are extremely useless on gas and fuel. So you look at any electrical quadcopter, any helicopter, anything with really any moving external airfoils, they can never fly anywhere remotely close to even half the speed of sound, right? Now, the jet engine allows your vehicle to accelerate easily to the speed of sound. And if you equip these jet engines with afterburners, you can even fly faster than the speed of sound. So this is the only kind of vertical takeoff and landing drone technology that allows you to reach such high speeds. And nobody else in the competition using electrical drones or propeller-based drones could ever attain such velocities.
What are the lift capabilities of the jet quad?
Sure. So for this very base model, which is kind of my starting point, nominally it is designed to lift a 40-pound payload along with a 40-pound of diesel or kerosene fuel. That's 5 gallons. And it'll be able to push it at a speed of about 250 miles an hour to a one-way range of 60 miles. That's kind of the nominal mission profile. Of course, if you don't need to go that far, you can put, instead of 5 gallons, you can put 2.5 gallons. And now, instead of a 40-pound payload, you can move a 60-pound payload. So you can essentially replace fuel and payload as much as you want, really based on ultimately what the client wants to do. But another important thing to mention is that we're using some of the smallest microturbine jet engines. These are 190 Newton engines. They make similar engines that are only slightly bigger in size that produce 400 Newtons and even 800 Newtons. So scaling up the vehicle is really straightforward. Anybody who's wanting to transport maybe a payload of 100 pounds, 200 pounds, even 300 pounds, it will be very straightforward to scale up the technology and build the necessary platform.
What do you see as the primary use case for the Jet Quad?
The primary use case is going to be emergency medical. First, we're going to start with emergency medical deliveries, whether it's heart delivery, organ delivery, blood delivery, applications that really require and benefit from the high speed. If there's an application that doesn't benefit from high speed, you really might as well go and use an ordinary little airplane or a quadcopter. So our starting point will be to deliver these medications as fast as we can. There's already been some interest expressed from companies in Africa and New Zealand to do just this. Now, that's, as I mentioned, is the starting point. Once we learn how to do it really well and we scale up, we then can do emergency medical evacuation. We would actually put a stretcher with a human on top of a platform like this, and then not just provide medicine in time, but evacuate a human. And the big reason for this, there's this golden hour rule, which essentially says that you have to act as fast as possible to get the human to a nearby hospital from the moment the injury has been inflicted, thereby greatly increasing survivability. And such a medical evacuation transport would be incredible, because a lot of times helicopters can't really access stuff to reach areas, very high altitude or maybe dense forest. But a vehicle based on the Jet Quad technology could do these very things.
Now, obviously, when you're talking about the distances and the speed for the Jet Quad, it's going to require a sophisticated guidance system. Is it autonomous, semi-autonomous, or pre-programmed? How does it work?
Fully autonomous. So even right now, the software that I have programmed is at a point where you receive a tablet with your drone, and you see the map on it, and you can touch panel, waypoint navigation, tell it to go and execute the mission, and it will do that completely autonomously. It would be nearly impossible if you try to fly this type of vehicle manually, because there is essentially 8 things that you're supposed to control at the same time: 4 engines, 4 thrust vectoring systems. Let the computer do it. That's what the computer is for.
I'm sure some are going to ask about the safety aspects. What can you tell us?
So right now we're still expanding the envelope to show that we can reach the speeds that we advertise. Once the envelope has been sufficiently expanded, then we can go into this redundancy, analysis. But the easiest solution to that, and one that I was always a big fan of, is to move to, instead of a 4-engine system, we move to an 8-engine system. So each one of the corners is now going to be equipped with a pair of engines, each with its own thrust vectoring system, but the vehicle will be sized so it can work easily on just 7 engines alone. So now, with 8 engines, you will have complete engine out capability. So if during your flight, any one of those 8 engines goes offline, you could still land safely, you could even still complete your mission.
What have been some of the challenges in bringing a system like this to market?
First and foremost is because now the paradigm in the current community is going all electrical with as many propellers as you can possibly fit. Everybody's doing this. And if the system that you propose is different from that, then people simply don't even want to look at it. Not to mention is that there is a big effort to go green and have everything electrical. Again, my system runs on diesel. It runs on heavy fuel, any sort of kerosene. I approach sustainability in a slightly different manner. I believe biodiesel has a lot of yet unexplored potential. And in the future, we could actually generate biodiesel from waste and use that to fuel these type of drones. So it is a completely new type of propulsion, a new type of aircraft that goes against the grain of what the community tells you must build. And so this has been the biggest challenge in terms of getting noticed.
Have you encountered any resistance from the FAA, NASA, or other organizations?
Specifically concerning FAA, they don't even have legislature in place to cover ordinary electrical drones. Obviously, liquid fuel jet powered drones is years ahead of what they could even think of. So my business is going to be based on a platform hardware provider. I provide the client with the platform, then they take ownership of it. Then it's up to them to fly it legally. It's going to be up to the client to make sure that they have all the necessary exemptions and licenses and plates to operate it wherever they want to operate it in the world. Now, in terms of NASA and most investors, specifically out of Silicon Valley, of course, electrification, eVTOL as they call it, including propellers, everything, this is what they're used to. This is what they want to see. I am not giving them that. I'm giving them something completely different. So even though its performance can be order of magnitude better than anything electrical out there, which it is, because liquid kerosene fuel has 40 times more energy density on a pound per pound basis when compared to lithium battery, even the best one out there. So I go to them and I give them this amazing solution, but because it doesn't fit what they think the future needs to look like, as I mentioned before, they simply overlook what I have to propose.
When did you start the company?
The company officially started in the summer of 2016 when it was incorporated and when the first original seed investment of $50,000 was received to begin construction of the first prototype. But leading up to this, there's quite a lot of history as to how the concept of FusionFlight had to be, and quite a lot of history as to how this sort of quad jet engine drone became a reality.
Where did the idea of starting a company for the jet quad come from? Is there a story behind it?
Sure, the actual story. Yeah, it's actually quite interesting. The actual story starts out in space, be surprised or not. For years, starting maybe around 2005 and later on down, myself and my dad, we really spent a lot of time trying to think of ways to send payload into space and make it very cheap and make it reusable. And this was really before SpaceX came out and totally conquered this whole entire arena. And what we came up with is this first stage for rockets that's fully reusable. Instead of using rocket engines, it would use jet engines, vertically oriented. And this would boost the rocket above the atmosphere, and then it would detach. And then this first stage with the jet engines would return to the launch pad, completely autonomously and land at its home position. Of course, SpaceX came around, proved that this idea is not needed because you can do all the same maneuvers with ordinary rocket engines. But by the time they came around the corner, I already started thinking about how to build a small-scale version of this air-breathing rocket stage. It was called an air booster. And I purchased my first microturbine in around 2014 to build this small-scale demonstrator. We had a small tethered test flight out in Arizona, and it turned out that it was a very unpowered vehicle. There was just not enough power. It was clear that we had to build this small-scale version using 4 tiny jet engines. And then when I started designing that, it became clear, you know what? Drones was becoming the hot thing. It was going to be much easier to receive investment as funding if this technology kind of morphed into a drone. And so this is kind of how the Jet Quad came to be, this small scale quad microturbine, booster stage. Now, of course, it looks nothing like a booster stage or a rocket, but it certainly has these sort of humble beginnings.
What has this experience taught you about the drone industry and about building a company?
The first lesson, of course, is people always talk about, how easy it is to find funding, and it's incredibly difficult. It is also very difficult to transition a product from prototype stage to a product stage. As a matter of fact, that transition is much more difficult than building a proof of concept out of a benchtop technology. And I think that's something a lot of people don't realize. They think that once you prove that the technology works, as I did, that it's all downhill from there. As a matter of fact, it's not. It only gets more difficult because now you have to repeat that reliably many, many times in a row. That's really a very complex task. And these are just but some of the lessons that I learned over the past few years.
What advice would you give to other entrepreneurs?
The biggest advice that I would give is absolutely never give up. I mean, everybody says it, but I can't reiterate it enough. Failing is absolutely a part of it. And as a matter of fact, it's a lot of failing. And it is just taking these punches in the face one by one by one. And it's you could be facing 100 failures in a row, 200 failures in a row. Just got to keep going. There's just no other way around it. You're not innovating if you're not failing.
What are the next steps for the Jet Quad?
I'm pursuing two paths in parallel at the moment. One is, of course, I'm doing qualification tests and wrapping up design of this pre-production model. And I'm doing it out of my garage in my house on my free time. And then in parallel is, of course, I'm heavily doing marketing and branding in hopes that eventually I can also find funding so that I can move out of the garage and establish a small facility and really dial into technology and start mass production. So those are the kind of two things I'm doing at the moment.
If there are potential investors listening to this podcast, what would you say to them?
I would say, look, here's the situation. The statistics show that by year 2027, the emergency medical drone delivery market is going to be worth nearly $1 billion and probably more than that. My system is order and magnitude better performance, fully reusable, much faster, more range, more payload, more speed. So clearly my product can dominate a very, very large section of this market by 2027. So there is a lot of money to be made with my product in that specific market.
And for my final question, Alex, what message would you like to leave regarding the future of jet-powered UAVs like the Jet Quad?
People need to be open-minded to new technologies and really don't constrain yourself in a box looking for the best solution, because solutions to problems in modern day can come in many different flavors. And being open-minded and finding the right solution is the only way to go to really forge a good future for drones. To make drones really useful in our society, all aspects, all types of propulsion need to be thoroughly explored.
That's it for episode 302 of the Drone Radio Show. I hope you enjoyed hearing from Alex Taits of FusionFlight. I want to thank Alex for taking the time to speak with me. If you want to learn more about the Jet Quad or want to connect with Alex, check out the webpage at FusionFlight.com. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.